Hi everyone, we're looking at arithmetic sequences today. Arithmetic sequences. Oops. Let's start with sequence. So, sequence, how about a list of numbers? 7, 11, 15. And let's ask the question, what's my rule? And by what's my rule, I want to find a way to describe this pattern. So maybe I could find the next one or the 40th one, some sort of way to describe this. So let's see. And I often find in this unit it's really helpful to have n and a sub n. N is our term number. Term number. And a lot of students find that these problems are much easier when they try and build a rule that's connected to the term number than when they try and build a rule connected here. Okay, so first term is 3, second term is 7, third term is 11, fourth term is 15. So what do we notice? Well, I see that these values are going up by 4, up by 4, up by 4. And you might think, well, when we come out to the nth term, maybe we should do n plus 4. Well, let's test that theory. These are our n values, and so we'll plug in 3. 3 plus 4 is 7. Oh, that didn't work at all. So this up by 4 thing, this is going up by 4, while this is going up by 1. And that's linear. Actually, this, and it's called a common difference. The common difference is the same as our m from linear equation writing. So my common difference here is 4, and I'm going to go with 4n. Now, I'm not expecting to get the rule yet. I've just taken the common difference and multiplied it by the variable n. And now when I try a value in like 3 times 4 is 12, and I see an 11 here. Or if I plugged in a 4 times 4 is 16, and I see a 15 here. What do I have to do to this rule to get the value I actually want? When I plug in a 2, I should get a 7, but when I plug in a 2 here, I get an 8. So I need to add or subtract to make that rule work. And in this case, I'm going to subtract 1. So let's test these values again. If we plug in a 3 times 4 is 12. 12 minus 1 is 11. Or 4 times 4 is 16 minus 1 is 15. And so now I can say that the rule here, what's my rule, is a sub n equals 4n minus 1. Now, again, this is the term number, and this is the value of the nth term. So if I see something like a sub 7, that means I'm supposed to replace n with 7 in the rule. So 4 times 7 minus 1 is 27. A sub 7 is 27. This is different than asking the question, for which term is a sub n equal to 32. So, oops, I meant 31. 31. And so let's, when we say which term, we want to find an n value. Okay, so I'll do 31 equals 4n minus 1. 32 equals 4n, 4n equals 8. The eighth term has a value of 31. Now, some students who don't want to be bothered by actually thinking, they just want to say, oh, you want to know the value of the eighth term? Well, they'll keep adding 4 and 4 and 4 and 4. But if I say, hey, what's a sub 350? Well, I'd have to add 4 a whole lot of times to get to the 350th term. But with this rule, I just have to plug in 350 and then subtract 1. So I'm going to have 200 plus 1200 is 1400 minus 1, or 1399 is the value of the 350th term. Okay, so we've talked about a lot of stuff here, including how do I build a rule. Well, in certain cases, what's my rule? I can find a common difference, and we call that D, by the way. And then I'm going to multiply the common difference by n. 3, I'm going to test an n value to see if d times n is the rule. Sometimes it is, but if it isn't, step 4, I'm going to add or subtract to make the rule work. I encourage a fifth step where you test again to make sure. Too often, students make mistakes when adding or subtracting, and then their rule is wrong. So I would encourage you to do this step 5. Okay, so let's see if we can apply this what's my rule technique here. And of course, that 5-step plan only works when we have a common difference. In fact, an arithmetic sequence is a sequence with a common difference. Okay. There are other types of sequences. There are other types of rules we could build, but when we see a common difference, 3, negative 1, negative 9, and so on, let's write the rule for this sequence. Okay, so again, I'm going to start with n and a sub n, 1, 2, 3, 4. And I notice that this goes down by 4, and down by 4, and down by 4. So I found the common difference is negative 4. And now I'm going to take that common difference, and I'm going to multiply that common difference times n. Third step was to test one of these n values. If I plug in a 2, the value should be negative 3. But if I plug in a 2 here, I get negative 8, not negative 3. What do I have to do to the negative 8 that I have to get to the negative 3 that I want? Is it add 5? Let's test. That's step 5. Let's test to make sure we figured out how much to add or subtract. If I plug in a 1, the value should be 3. 1 times negative 4 is negative 4 plus 5 is 1. That's not 3. So this number is not correct. Let's see that again. If I plug in a 1, 1 times negative 4 is negative 4, and I want positive 3, I'm going to have to add 7. Okay, if I plug in a 2 then, 2, I get negative 8, plus 7 is negative 1. See, that's why I like step 5, test again, just to make sure you added or subtracted properly. Alright, so here's our arithmetic rule for this sequence. Now, I don't know if you noticed this, but this is very similar to y equals negative 4x plus 7. And in fact, you could think of these kind of like synonyms, where these are ordered pairs, except instead of x, y ordered pairs, we've got n comma a sub n ordered pairs. And this d that we found is just the slope n. The amount that we add or subtract to make it work, that's our b value in y equals mx plus b. So we've got a lot of familiar territory here when we talk about these. So what's the difference between them? Well, so here's the thing. The line y equals mx plus b, the negative 4x plus 7 equals y. That's this line. 0, 7, 1, 3. I guess that would be a little lower. 1, 3, 2, negative 1, and so on. So these points are contained on the line y equals negative 4x plus 7. But so are all these other points here. There's an infinite number of points between n equals 1 and n equals 2. Okay, so this contains an infinite number of points, all the points. Whereas our sequence, while it's also infinite, doesn't contain any of these. Nor does it contain these or these. In fact, ours doesn't even contain that point. It starts with 1 and goes down from there. And so these dots would sit on top of the line negative 4x plus 7, but there are many, 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 many fewer points in this sequence than there are on the line y equals negative 4x plus 7. Having said that, we can really use that understanding that an arithmetic sequence is really just a linear equation model that we're making. So let's see if we can find a rule here. 1/8, 1/4, 3/8, 1/2. Can we come up with a rule for this sequence? Well, is it arithmetic? Does it go up or down by the same amount each time? If I make these all have a common denominator, maybe I'll see something. 2/8, 3/8, 4/8. Oh yes, it looks like we're going up by 1/8 each time. So when we go to build that rule, let's take that 1/8 and multiply it by n. Is this our rule, we ask? Okay, so remember, we have n and a sub n. If we plug a 1 in, we should get 1/8. 1 times 1/8, why, that's 1/8. And so that's our rule. Let's just test another value to make sure. If I plug in a 3, I should get 3/8. 3 times 1/8 is 3/8. So this is our rule. Sometimes we don't have to add or subtract to make the rule work. Sometimes this is all there is, just multiplying d times n, the common difference, times our input variable, the term number. Now, I know that some of you are thinking, well, Mr. Kukla, couldn't I just, add 1/8 each time? Or in that first problem we did 3, 7, 11, 15, and then the sequence continues. Couldn't I just add 4 to this value? Yeah, and you could write that this way. A sub n plus 1 equals a sub n plus 4. Yep, that means if I want to find a sub 2, a sub 3, that's going to be a sub 2 plus 4. Well, a sub 2 was 7. So we would do 7 plus 4 equals 11. And that's a sub 3. Sure, that's a sub 3. I got you. And then if I wanted a sub 4, I take a sub 3 and add 4 to it. And so that would give me 11 plus 4, or 15. And so now I know that a sub 4 is 15. Sure is. But what happens if we have a sub 350? Well, in order to use this model, it's, by the way, called a recursive model because it requires you to know the value of the previous term in order to find the next term. We would have to know the value of a sub 349 plus 4. Well, I don't know a sub 349. So I'd have to find a sub 349, which would mean I'd need a sub 348 plus 4. But I don't know a sub 348. The last one I know is a sub 4. And so I'd have to keep adding 4 and adding 4 and adding 4 and adding 4 until I got to a sub 350. That is crazy. I never want to use recursive. So even though I see I'm just adding 4 each time, I don't want to use that model. That's a horrible model. That's my model of last resort. Whenever I have an arithmetic sequence, whenever I have a common difference, where the term values go up or down by the same amount, that's when I say, oh no, let's write a rule for that that's an arithmetic rule. Okay, so next we see some homework directions. Determine if the sequence is arithmetic. Determine if the sequence is arithmetic. Well, we know if it's an arithmetic sequence, it has a common difference. So, 10, 8, 6, 4, 2. Is this arithmetic? Goes down by 2, goes down by 2, goes down by 2, goes down by 2. We have a common difference of 2, so this is arithmetic. How about this sequence? 1, 2, 4, 8, 16. Does it go up by the same amount each time? Plus 1, plus 2, plus 4, plus 8. Ooh, freaky. What it goes up by is these values. But that's not the same amount, so this is not arithmetic. These are going up not by the same amount, but they're multiplying by 2 each time. And so in a case where we're not adding or subtracting to find the next term, but we're multiplying or dividing to find the next term, that's going to be the hallmark of a geometric sequence. And we'll see videos for those in the future. Okay, what's next? Oh, how about one for you? Why don't you determine if this one is arithmetic or not? 9 fourths, 2, 7 fourths, 3 halves, 5 fourths. Is this an arithmetic sequence? Pause the video, give it some thought, try it out. When you're ready, come back. Welcome back. So in order for me to check, I really want to make some common denominators. And when I make common denominators, I see pretty quickly that we're going down by 1/4 each time. So the common difference is 1/4. And so therefore, since there is a common difference, this is an arithmetic sequence. Okay, next. They ask us to write the first 5 terms in the sequence. Okay, so we've been given a sub n equals 5 plus 3n. Okay, so if I want to know the value of the first term, 5 plus 3 times 1 is 8. And if I want to know the value of the second term, 5 plus 3 times 2 is 11. And if I want the value of the third term, that's 5 plus 3 times 3 is 14. Yep. A sub 4, 5 plus 3 times 4 equals 17. And a sub 5, 5 plus 3 times 5 is 20. Now, some students identify this as the common difference. And so once they find the first one, aha, I know a sub 1 equals 8, then they just add 3. A sub 2 is 11, a sub 3 equals 14, a sub 4 is 17, a sub 5 is 20. And of course that will always work. That's certainly preferred for speed, and this one tells us how we're generating these values by using this sequence. Okay, so either I'm going to find the value of the first term and keep adding the common difference, or I'm just going to be plugging in the first 5 term numbers into the rule. Now, in addition to our rule, which kind of looks like y equals mx plus b, there's a general rule for a sub n, which is a sub 1 plus n minus 1 times d. So we'll be writing rules using this model, but we'll also be seeing some rules in this model. So a sub n equals 5 plus n minus 1 times negative 2. And they want the first 5 terms. Well, again, we can do this lots of different ways. First, we can find a sub 1 by plugging in a 1 there. 5 plus 1 minus 1 times negative 2, which is 5. Oh, right, that was a sub 1. And then a sub 2 would be 5 plus 2 minus 1 times negative 2. So 1 times negative 2 is negative 2 plus 5 is 3. A sub 3, 5 plus 3 minus 1 times negative 2. That's going to be negative 4 plus 5 is 1. A sub 4, 5 plus 4 minus 1 times negative 2. That's going to be negative 1 because we have negative 6 plus 5. And finally, a sub 5, 5 plus 5 minus 1 times negative 2, or negative 3. Or, of course, we could identify a sub 1, we could identify d and say, all right, I start with 5, and then I go down by 2, and down by 2, and down by 2, and down by 2. That'll work too. Also, you might think to apply some algebra to this and distribute. And so you have a sub n equals negative 2n plus 2 plus 5, and then combine like terms to get negative 2n plus 7. If you find it easier working with this tidy rule, that's great, use it. Otherwise, feel free to use this given rule, a sub 1 equals n minus 1 times d. Okay. So what's next on our list to do? On our list to do is write the first 5 terms given. A sub 1 equals 2 and d equals 5. And some students say, well, great, I'm just going to, I'm just going to start with 1 and then add 5 each time. So a sub 2 is 7, I'm going to add 5. A sub 3 is 12, I'm going to add 5. A sub 4 is 17, and I'll add 5. And a sub 5 is 22. That's one way to approach the problem. The other is to build the model. So remember, a sub n equals a sub 1 plus n minus 1 times d. And where we're headed with these problems, this is probably the most useful approach. So we'll build this rule. We've got 2 plus n minus 1 times 5. And if we tidy this up, a sub n equals 5n minus 3. And now, if we want to find the value of the first 5 terms, well, we already know a sub 1 is 2. A sub 2 would be 5 times 2 minus 3. A sub 3 is going to be 5 times 3 minus 3 is 12. A sub 4 is going to be 5 times 4 minus 3 is 17. And then finally, a sub 5 is going to be 5 times 5 minus 3 is 22. And so we can get all 5 values by building the rule and then using the rule. That's certainly a long method to do this. I think it's probably easier to say, oh, if a sub 1 is 2 and d is 5, we could just start with 2 and keep adding 5 until we get to the 5th term. But if the problem gives us something different, for example, a sub 1 equals 3 and d equals negative 2. I've actually seen students do this and get it wrong by just saying, oh, I'm going to subtract 2 each time. You would think it should be really easy to just subtract 2 each time. And I'm not sure what it is, but for some reason, some students, yeah, they have a real difficult time, especially when the d value is negative. But for us, again, I think, a sub 1 equals a sub 1 equals 3 and d equals negative 2. We can build that rule a sub 1 plus n minus 1 times d. And we'll plug in what we know. We know 3 plus n minus 1 times negative 2. And if I tidy this up, negative 2n plus 5 is a sub n. And then I could plug in my values 1 through 5 into this to find the first 5 values. And you think, well, no, really, I'm just going to do it that first way you showed me. Okay, yeah, that's fine. So what if they tell us instead that a sub 4 is negative 7 and d equals negative 3? And we want the values of the first 5 terms. So we want a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Well, we know this one. And so some students still say, okay, I'm going to subtract 3. Oh, but wait, how do I find these? Do I subtract 3 again? No, I'm going backwards, so I have to add 3 to get those. And we can certainly do this problem that way. Or we can build the rule. A sub n equals a sub 1 plus n minus 1 times d. Now, I don't know a sub 1 this time. I do know a sub 4. So remember, that's n equals 4. So the value of the 4th term is negative 7. Negative 7 equals a sub 1 plus 4 minus 1 times negative 3. We know the term number is 4 because this says a sub 4, so n equals 4. We know the d value, and so we can solve for a sub 1. And we get 3 times negative 3, a sub 1 equals minus 9. And so a sub 1 is negative 7 plus 9, or 2. A sub 1 is 2. And then, subtracting 3 from there, a sub 2 is negative 1, and subtract 3, a sub 3 is negative 4, and a sub 4 they gave us is negative 7, and I subtract from there to find a sub 5, and I get negative 10. So there's a a rule-based approach to this problem, where I find a sub 1. In fact, I could also, since I found a sub 1 equals 2, and d equals -3, I could build that rule. I could go back and say 2 plus n minus 1 times -3, a sub n equals -3n plus 5, right? And then I could just plug in 1, 2, 3, 4, and 5 here. That'll work as well. And that's a method that we'll be using in problems in a few minutes, actually. Okay, so now write the arithmetic rule in each case. Let's see if we can put it all together now. Feel free to use the what's my rule approach that I showed you at the beginning of the video, or a sub n equals a sub 1 plus n minus 1 times d. That is also fair game for these problems. Okay, so here's the first one. 4, 3 halves, -1, -7 halves. Okay, please write the arithmetic rule for the sequence. We're told it's arithmetic, so we know there's a common difference. We just have to find that common difference. Again, I think sometimes common denominators can be helpful. So this would be 8 halves. This next one is 3 halves. This next one is -1 half. Huh, that can't be -1 half, can it? Oh, that's because it's -1, so it's -2 halves. That's better. And -7 halves. Okay, so what do we see? We're going down by 5 halves, down by 5 halves, down by 5 halves. So we know d equals -5 halves. And we see a sub 1. A sub 1 equals 4. So I write my rule as a sub n equals 4 plus n minus 1 times -5 halves. Or a sub n equals -5 halves n plus 4 plus 5 halves. That's 8 halves plus 5 halves is going to be -5 halves n plus 13 halves. There's our arithmetic rule. Ta-da. Okay, so how about you try these? Again, just write the arithmetic rule: 4, 7, 10, 13, and so on. Pause the video, give that one a try. Okay, any luck? I notice this goes up by 3 each time. So I'm going to take that common difference of 3 and multiply it by n, 3n, a sub n. And if I plug in a 1, I should get 4, but 3 times 1 is 3, not 4. And if I plug in a 2, I should get 7. 3 times 2 is 6, not 7. So I think I need to add 1 to make this work. Let's test a value, like a sub 4 should be 13. 3 times 4 plus 1. Why, yes, that is 13. So there's my rule. Again, I can use either what's my rule or that general arithmetic model that I used in the last problem. What can you get with this one? A sub 1 equals 5. A sub 4 equals 15. Okay. So in this situation, we're asked to write the arithmetic rule. Here, I don't know what d is, but I do know that when n is 4, a sub n is 15. So I can use a sub n equals a sub 1 plus n minus 1 times d. Let's plug in what we know. We know a sub 1 is 5. We know n equals 4. We don't know d, but over here, we know a sub 4 is 15. So 15 equals 5 plus 3d. Or, 10 equals 3d, where d equals 10 divided by 3. Well, that's great that we have a d value, and we have an a sub 1, but we're not done yet because we were asked to write the arithmetic rule where d equals 10 thirds and a sub 1 equals 5. Okay, so let's write that rule. A sub n equals a sub 1 plus n minus 1 times d. I'll plug in what I know. 5 plus n minus 1 times 10 thirds. I'll distribute that 10 thirds and get a sub n equals 10 thirds n. That means it goes up by 2 and 2/3 each time? No, 3 and 1/3 each time. As I go from one term to the next. Minus 10 thirds plus 5. Well, 5 is 15 thirds minus 10 thirds. So I can tidy this up to be 10 thirds n plus 5 thirds is a sub n. Okay, so even if they don't give me a whole lot of information in the sequence, I can still write a rule for it. You try this one. A sub 3 equals 94. A sub 6 equals 85. A sub 3 equals 94. And a sub 6 equals 85. Give that a try. Okay. Oops. You can't see that. A sub 3 equals 94. There. So, pause the video, give this a try. Welcome back. So in this problem, I don't know a sub 1, and I don't know d. I don't know either of them. But I do remember that d is a synonym for m. And I do remember that when I see these things, I can think about them as ordered pairs. 6, 85, and 3, 94. Now, there are some students who say, okay, if I go down by 3, I get to 91. I go down by 3, I get to 88. I go down by 3, I get to 85. So I must have minus 3n. But most students can't do that. So instead, what I'm going to say is, well, let's use our slope formula. 85 minus 94 over 6 minus 3. And so that's negative 9 over 3, or negative 3. Now that's slope formula, but that's also d. So now I know d and two values from my sequence. I can plug those values in and get, I'm going to use this value. And I'm going to say 94 equals a sub 1 plus 3 minus 1 times negative 3. Right? This is my n value. This is my a sub n. So I've got 2 times negative 3, which is negative 6. I add 6 to both sides and find out that a sub 1 is 100. Okay, so can we make this rule now that we know a sub 1 is 100 and d is negative 3? Sure, we can say a sub n equals 100 plus n minus 1 times negative 3, or a sub n equals negative 3n plus 1 over 3. Ta-da! Even when the sequence values aren't next to each other, if we know it's an arithmetic rule, we can certainly apply what we've learned both in this video about arithmetic sequences, but also with our algebra knowledge about linear equations and their slopes. We can apply that knowledge to help us out here. Okay, two last problems. A sub 5 equals 190, and a sub 10 equals 115. Why don't you give this one a try? This one should probably be easier after having done the last one. Okay, so I know that m equals d is 190 minus 115 over 5 minus 10. I get 75 over negative 5 or negative 15 equals my d value. D equals negative 15. Okay, I don't know a sub 1, but I know a sub 5, so a sub n equals a sub 1 plus n minus 1 times d. Let's plug in an ordered pair. 190 equals a sub 1 plus our n value is 5, and our d value is negative 15. And so I get 190 equals a sub 1. This is going to be 4 times negative 15, or minus 60. If I add 60 to both sides, I find out that a sub 1 is 250. So I now know my d value is negative 15, my a sub 1 is 250. So we can say a sub n equals 250 plus n minus 1 times negative 15. Or negative 15n plus 280 is our rule. Okay, last one of these. Oh, and of course you could always check by plugging values in. If I plug in 10, I should get out 115. So negative 15 times 10 plus 280 is, I don't get that out. I must have made a mistake. Well, let's go back and check. So 190 minus 115 over 5 minus 10. So I get 190 minus 115, all divided by negative 5. Yeah, divided by negative 5 is 15. So this is negative 15 equals t. Okay, and so then I plugged in 190 equals a sub 1 plus 5 minus 1 times negative 15. And I got 4 times negative 15 is minus 60. 190 equals a sub 1 plus negative 60. I add 60 to both sides. I get a sub 1 equals 250. Well, that's good. So what's missing here? Keep going then. So we know that a sub n should be a sub 1 plus n minus 1 times negative 15. And that's going to be plus 15, not plus 30. Okay, so a sub n is negative 15n plus not 280, but 265. And now if I plug in a 10, a sub 10 is supposed to be 115. Let's just confirm that. Negative 15 times 10 plus 265 is negative 150 plus 265 is 115 for a sub 10. Nice. Good job, us. Okay, well, in our next video, I said I was going to do one more. Yeah, I think I'm going to stop. In our next video, instead of looking at arithmetic sequences, we're going to look at arithmetic series. And that's the sum of an arithmetic sequence. So instead of 3, 7, 11, 15, a sequence, we're going to be looking at 3 plus 7 plus, we're going to say a sub 1 equals 3, and a sub 2 equals 3 plus 7, and a sub 3 equals 3 plus 7 plus 11, and a sub 4 equals 3 plus 7 plus 11 plus 15. And so we're going to be adding up the values in the arithmetic sequence. Okay, so watch for that in the next video.